Hi students. So today we're going to be talking about the Sea Level Lab and how to manipulate files and get the data that you need. In the first part of this lab, you're going to be looking at tide gauge data to look at recent sea level rise since about 1940 or so. And this is a KMZ file that you will load into Google Earth. And what I recommend you do is you load it, and then basically it's very, very straightforward. What you're going to want to do is zoom in. So I've loaded it, and now you can see my dots appear on my map. This is just the US. The data are global though. And you can see the dots appear on the map. The different colors are the time intervals. So the last reported year is in green is 2016. Generally, we don't tend to use the older sites which stopped recording in 1998, etc. So we're going to be looking mostly at these green dots, and I'm going to give you the name of a station and a state. So you're going to have to cruise around a little bit and look for them. So let me just pull up one of these records. Let's look at the east coast of Florida. Let's zoom in a little bit. Let's say we're going to look at the east coast of Florida, and I'm going to click on this guy here. You can see that there are two dots that show up. It doesn't really matter which one you choose. I always tend to choose the one that's in the ocean. If you see two dots that have different colors, you're going to want to choose the most recent one. So generally choose the green one. If there's like a yellow one and a green one, choose the green one and click on it. And then it says Trident Pier Port Canaveral, and I'm going to click on the PSMSL ID number. And it's going to open like a little web window here in Google Earth for you. And you're going to see down here, this curve is what you want to be looking at. It's the monthly data in millimeters. Okay, these are millimeters. So 7,000 millimeters, 7,250 millimeters. This is 250 millimeter difference, which is 250 millimeters is 25 centimeters. Okay, so you can see a 25 centimeter difference from here to here. And you're going to be looking at trends. So in this case, you can see that the sea level is rising. It's kind of slow. You're going to want to be looking at the middle of these annual variations, which are to do with tides and all sorts of other phenomena. All right, so you're going to want to look at the averages, and you can see that it's rising from about 7,000 here in 1995, which is the beginning of your time series. And up here, it's averaging somewhere in the middle, maybe up here, just about 7,200 or so. So it's sea level is going up as shown by this tide gauge data. So you're going to be looking at a bunch of stations from different places and answering questions about what the trends are. Is sea level going up or down? And this, remember, is relative sea level. So it is sea level relative to the coastline. And in some cases, just to tell you, the relative sea level is actually going down, which means the land surface is rising up. So this kind of a cool lab because you're going to be looking at a very powerful data set, the tide gauge data. All right, so that's that. It's pretty straightforward. So I'm gonna get out of Google Earth. I'm gonna quit Google Earth, and now I'm gonna keep looking at this is the sea level rise data set, which is a really cool data set because it shows you flooding maps for what happens when we raise sea level. And the first thing I want to do is I want to change this to feet, meters. So I'm going to change to meters. Unfortunately, it's underneath my recording button, so I'm not sure I can actually do that. But you're going to want to change it to meters. This is a foot scale, and if you click down here on the bottom, you'll see that it allows you to click on the knob, which I can't do, and change it to meters. Okay, so you're going to be working in meters. And then there are several things you can do. You can raise sea level 2 feet, 3 feet, 4 feet. Doesn't show a whole lot till you move close. So let's look at Houston, Texas. I'm going to zoom in on Houston because it's a pretty low-lying area. It's not one of the ones we deal with, though. Let's look at the coastline in Houston. And you can see it's a really nice Google Earth map. You can actually go up here and you can look at base map, street view. So in some cases, I'm having you look at street view. In some cases, I'm having you look at satellite view. So it's kind of cool. If you live in a coastal area, you can see the street you live on. And now you can see what happens when I start raising sea level 5 feet, 6 feet. You'll see that not much is happening over here, but if we move up here, you can see there's a lot of flooding right in this part of Houston. You can see it's, oh, so if I go back to 1 foot, 2 foot, 3 foot, 4 foot, 5 foot, you can see the progressive flooding. So that's one thing that you're going to want to look at in this lab. The other thing that's really cool in this lab, and I'm going to go back to street, and where's my, I want to move out. Let's move over here. This should be my, why is it not letting me move out? There should be a scale over here, base maps, opacity. I'm not quite sure why it's not letting me move out. That should stay here, okay? So actually, you know what I can do? I can enter an address. So this is a cool thing. I actually have you do this. So Miami, Florida. Actually, let's not go to Miami because that's an area you're going to be dealing with. Let's go to another coastal city. Let's look at a flat coastal city. Let's go to Mobile, Alabama. Mobile, Alabama. And now it's going to take me there. Okay, so here we are in Mobile. Obviously very low lying. And there's 5 foot of sea level rise in Mobile. Go back down again, 3 foot. You can see the water goes out, but boy, it's flooded this area pretty well. I'm going to go back out to satellite view, okay? And what you can look at on the left side here is you can look at flood frequency, which should give you an area in red, very similar to that other map showing you how frequently that area floods, but you'll also notice that the areas around these creeks are flooding a lot as well in red, so that's the flood frequency. And the other thing we have you look at is this vulnerability map, which I find really interesting. And you look at the vulnerability map, and it tells you a lot. So there's not a lot of construction here, so that's why that's not that vulnerable. But if you look at Mobile, most vulnerable is in red, and least vulnerable is in pink. And you can tell differences between different areas in terms of their vulnerability. And what it means is that the vulnerability is not just the susceptibility of an area to sea level rise, but it's also how vulnerable the population is. So for example, if you're looking at the inner city, where there's a lot of poor people who can't adapt to sea level because they don't have the resources, that's going to be an area that's more vulnerable to sea level rise than if you're looking at downtown Manhattan where everybody's millionaires, okay? And so that's just an example. And this is like the sort of a sociological side of sea level change that I find so interesting, and I hope you will too. So you're going to be looking at a combination of the sea level rise view. So this is where, whoops, let's get started again. So you're looking at the sea level rise view, you're going to be looking at the flood frequency view, and you're also going to be looking at this vulnerability view. And to move around from area to area, because oh yeah, here it is. Look at this. Oh, there it is. I just lost it. I'm thinking I'm in Google Earth, but here it is down here. Just enter these addresses where you want to tootle around to. So enjoy yourselves. I think it's a lot of fun. It's a really interesting lab, and you can tell I'm really enthusiastic about it. So we'll talk to you later on.